Welcome to Made in Science, the official podcast of the University of Stuttgart. A friend of mine likes to say, Wolfgang, you can run, but you can't hide. I happen to think one of the aspects and developments that we really cannot run from, and also none of us can hide from, is artificial intelligence. Our guest today knows all about it. Marco Aiello is Professor of Computer Science and Head of Service Computing Department here at the University of Stuttgart. His research interests are in service computing, smart energy systems, and spatial reasoning. He has authored over 160 peer-reviewed articles and several books, including 2 bestsellers. And the most recent one being The Web Was Done by Amateurs. Very nice meeting you, Professor Aiello. How are you today?
Thank you. Hi, nice to meet you, Wolfgang, and glad to be here.
You mentioned in one of your lectures that I happened to watch online a combination between artificial intelligence and a tsunami. Well, in my understanding, a tsunami is something we cannot stop. We might be able to prepare for. It is dangerous. It occurs instantly. It might build up. It's destructive. So I wonder, how do you want to use this metaphor in connection to AI?
Yeah, indeed. So tsunami is hard to predict because it's tied to earthquakes. And it requires some preparation. So I think in some villages in Japan, they even had prepared walls to fight the water flow. And I use that metaphor because I thought that there is a radical change in computer science with the recent developments in AI. And also in other sciences. So this is what I think we're witnessing, that all the sciences are affected by it. So a tsunami is a representation of something major, disruptive, and in that talk, what I bring it back to is a paradigm shift, right? So it's a paradigm shift is a word that's often used in science, saying this technique, this technology, this discovery brings a paradigm shift. And the word comes actually from a philosopher of science, Kuhn, who studied how physics and valuations in physics have changed over time, and said, well, the world doesn't go in a linear ways, especially scientific world, but there's major breakthroughs and changes that occur at some point in time. And this causes a paradigm shift. And he uses the examples from astrophysics, from natural sciences, and so on. And I find that very, very fitting to our current situation, right? So computer science is a young discipline. We have evolved very, very fast. And now suddenly we have this new tool that seems to change, if not everything, a lot. And AI is not a new discipline. I mean, we used the term since 1956, and before there was also some work from Turing on machine intelligence. So it existed for a long time, and it often provided a lot of hope for new technologies and new possibilities. At some point, there were disappointments. These are called the winters of AI, in which sometimes things were a bit overpromised. And now, again, we have a big, big excitement. I mean, AI is a marketing tool, is something you have to have in your products. In science, what you see is that there is a major shift in the techniques that are being used to conduct science and the type of results that people are seeking.
Your research spans services, AI, and sustainable energy systems. How would you describe your main research focus?
Yeah, so we look at systems architectures and how we can make systems that work effectively in practice. And then often we resort to techniques that come from AI. In the old days, so when I started in this field 20 years ago, we were using more formal methods, so precise mathematical approaches. And more recently, we're using more statistical methods. So large language models is a classic example of that. Well, classic by now. So AI and AI-related techniques has always been kind of the core of my research work. And then the application can vary. So we've been interested in the past in smart energy systems being smart grids, smart buildings, smart homes, and more recently also data centers. And how do you make these technologies useful for the environment and at the same time that they're not themselves too bad for the environment? So typically we talk about green ICT, but also ICT from green systems.
So that's about the topics. When we look at the various disciplines, your team combines engineering, computer science, and social sciences. How does this interdisciplinary collaboration work in practice? Can you give us an example for this?
Sure, I think it's essential. The problem that typically engineers, including myself, have is that we think of a system with all its beautiful features, but we don't think of the fact that it has to be used. And there's where, for instance, the psychologists or the people more expert in human-computer interaction play a crucial role. So an engineer typically thinks, oh, let's have this beautiful dashboard with 6,000 buttons in which you can control and see everything. But the average user is just going to be overwhelmed by it and annoyed. And so working with environmental psychologists, especially I worked with a colleague from Groningen, Professor Linda Steeg, has been essential for me and especially for our group to really understand also the user side. And especially when you build systems that are in the offices, in the homes, that have to do with the energy that the users use, you cannot ignore that. And it's a mistake that myself I've done many times. It's a mistake that it's unfortunately common. So I encourage a lot to have this kind of interdisciplinary work. We work with environmental psychologists on energy themes, also with economists and with power system experts. And clearly we cannot be expert in everything, so we need that multicultural. And with respect to this, I also have to say that of my PhD students in the past, I have not only hired computer scientists, right? So for instance, at some point I hired someone with a degree in power systems because I thought, oh, I can teach computer science to her, but I would like someone who understands the system and know how to model it. And I think that was a very successful project.
And from that successful project, there are also challenges, of course, that AI comes up with. One of the current dominant one, perhaps, are large language models that are rapidly changing research. What changes are you observing and in your science, in your field of work?
So several changes. The first change is that the word AI, large language model, appears way more often on papers than it used to be. So I think right now there's a growth that depends on the fields, but up to 1,000% in how many papers use the term AI. And this is not only computer science, also in engineering and agriculture. So every field is affected. And the second one is methodological. So computer science tradition has been a formal method discipline, or for a large part. So more mathematical oriented. And now we have become almost a phenomenological science. And so we take a bit of LLM, we throw in data, and we see what comes out. And we observe the outcomes rather than design them. And this is interesting because, of course, it brings a different methodology, but also a different way of working. And it's possible because these large language models are very good at many tasks, right? So this makes it feasible. At the same time, there's this impression of lack of control, which is worrisome. Like there's an hallucination. Can I justify it? How do I know that the result that I got is correct? So 20 years ago, I would build a system and then I could prove that the output is correct. No matter the input, I can prove it's either correct or it doesn't give an answer. Now I get an answer which I don't know if it's correct. It could be correct. I could try to check it somehow, but I don't have that by design. So it's a completely different way of working. The huge advantage is the accessibility of the technology. So it's very easy to build systems, it's very easy to program components, so it's very easy to run an experiment and write about it.
At the same time, you have also hinted at risks like an increasing publication volume when it comes to this and other topics. You are on editorial boards of several international journals in your fields of research. From your experience, are we facing a kind of inflation, inverted commas, of knowledge?
Absolutely, we are. So from 1st of January, I also took the role of editor-in-chief of IAAS Transactions. And the amount of papers we receive on a daily basis is astonishing. So these tools have brought an ease of doing research and also an ease of writing about research, and that is reflected in the numbers. So the journal I'm currently managing used to have 300 submissions per year. Last year we had more than 1,600, and I project this year we're going to go above 2,000. And this puts a huge strain on the old editorial board because you have to manage those papers and you have to do it seriously. And also it hinders the possibility of the quality, so you have to make sure that the things are qualitatively good. Checking for plagiarism used to be an issue that doesn't exist anymore, but it was easier than checking for content which is generated that doesn't make sense. That requires a deeper look into the content. So I think in all the fields, not only computer science, there is an inflation of papers and there is a need for reflection. So I heard this from several colleagues, like, is the current publication model still sustainable? And I don't think anybody has the right answer, but the system is coming to an explosion. So last year at the conference on AI called Triple AI, they received 29,000 submissions. 29,000. They desk rejected 4,000, and they still reviewed 25,000 papers. This is a huge effort. It's a huge effort. So now I saw some conferences are putting models in which you have to pay for every second submissions you are going to send. Other types of things of blocking. The extreme of this view is colleagues that say every scientist should publish at most 5 papers per year, not 70 or 100, like some people do. There is no clear solution to this, but the problem is becoming more and more apparent. And I think AI accelerated this. I don't want to say it started it because I think there was hyper-productivity before, but clearly it has made the problem more evident. And I think the scientific community and the publishers have to make a serious reflection on what is a sustainable dissemination model. Clearly there's different interests. One interest is economic from the publisher, one interest is from the scientists to disseminate, and that is also related to careers. So it's very hard to find an easy solution to the problem.
Easy solutions are never around. That much we know. Wherever we turn, also in your cooperation with the automotive industry, I would expect no easy solutions, but still lots of services available and upcoming. So in your cooperation with the automotive industry, how is the car, in your perspective, evolving through software and digital services?
Yeah, so this is a new passion that I started coming to Stuttgart. It's something that I was not exposed to before, and I'm glad that it actually happened. So I enjoy working with the automotive industry, and the vision that I see, but it's not mine. I mean, many people have mentioned this, is that the car is becoming more and more of a software object. So the mechanical part is still central, of course, otherwise the thing wouldn't move. But the software control and the software that it's in the car to help the car running and the user have a good experience and a safe experience is growing in an incredible way. So in this setting, for us, it's interesting to look at how we can have the dynamic aspects added to the car. So how can a car, for instance, interact with an infrastructure and take advantage of services which are available locally? So things that happen to be in the same neighborhood of the car or things which are remote. And there's a lot of possibilities. So we can bring a lot of ideas that we already had in the world of the web, or in the world of enterprise integration. We can bring them to the car. Of course, there's strong requirements. So the car has much stronger requirements in terms of real-time control, in terms of safety, in terms of regulation, that often we did not have in other environments. But these challenges are also fun to work on and to play with, let's say.
What kinds of services could realistically appear in the cars of the future? When are you dreaming in this, kind of field? What do you think, or what comes up in your dreams?
Well, the dream is like all technologies that we work with, that it understands, right? So right now you have to give instructions to my devices, and I'm frustrated when they don't work. So I take the phone, I want to do something and I can't, or I input something and I don't get the outcome that I want. So that kind of frustration I have sometimes also with a car when it does a stupid decision. So I would love a car that can really understand what I want and do it for me. This is clearly goes in the direction of autonomous driving, so it would be nice if it drove itself, but also in the terms of the services that I can have from the car. So while I'm driving, why can't I already, for instance, answer to some emails that or some other messages that I received? Why can't I ask it to fix something in my agenda and perhaps change the route to wherever I have to go? So we're seeing some initial results in that direction, but we could see much, much more. And the car could even be proactive and suggest something. So, okay, you need to stop because you seem to be tired. I found this that I know you enjoy. Let's go together to that restaurant, or together, okay? Let's drive to that restaurant and then be there. So this ability to first understand well what the user wants, perhaps predict what the user wants, and relate it to the outside environment. And the word services for us there means see the world as a set of services that you can actually interact with. So also a restaurant is a service, also a calendar is a service. So anything that is giving you functionality of some type can be seen as a service and then integrated into the car experience.
To do your research for these topics, but also many others, of course, energy comes in as well. Energy consumption in IT and data centers is a growing concern. How big is the problem really in your mind? And why is it perhaps underestimated? Are we just beginning to address this issue? Because we also live in a time where we see things, begin to see things and address them in a more complex way. And that's a good sign in my mind, of course. But it is a growing concern. How big is the problem really?
So as you said, it is big and it's growing, so it's getting bigger. In the past, in computer science, I don't think we were really much concerned about energy, right? We were more concerned about computation and the power of the computation we could reach. And recently we started to say, well, we have these data centers, we have these cloud services, it's really nice, but they actually consume some energy. And we realized that it consumed a lot of energy. And AI made the problem all the worse. So the amount of energy that you need for training these huge, large language models and to do inference on them is really major. There's a lot of funny examples, or kind of funny examples of this, in which basically a data center steals a lot of power from a village, or steals a lot of water, which is used for cooling, reducing the amount of water the village has. So it's something that we used to neglect, and now I see there is a great attention to it. It is not still a central requirement when you build an information system, but my hope, and one of my colleagues which we work with, is that it will be. So in the old days, if you look at computer science and how we build systems, we were concerned with functionality. How can this software do something? At some point, especially when the internet became bigger, we started realizing the dangers of security. And we started saying we should put security as a central requirement for our systems, and we got better at that, I think. I mean, there's still security issues, but the techniques that we use are much better. And my claim is that now we should put the environment and sustainability as a central requirement. So designing systems which are sustainable by design, and not use that as an afterthought. And in general, the consumption of data centers and ICT infrastructure has grown as a percentage of the global demand of energy. It used to be around 2-3% worldwide. Right now it's believed to be above that and is projected to go at 10-12%, which is a huge amount. So it's something that we need to be prepared to deal with. Sam Altman from OpenAI said that the biggest limit to AI is the amount of power you can have. And some countries seem to have been well prepared for this and equipped themselves well. So some countries have a huge capacity of energy generation, which can help them with AI. Some others seem to be lacking behind, so not as well prepared for that huge energy need which is there.
Just to stay with this for a moment, what would need to change for green IT to become a standard approach with the figures that you just mentioned and the growth that is expected to happen?
Yeah, there's a lot of challenges there that we're actually looking into. So one challenge is that of accountability. So modern ICT systems are highly distributed, are highly layered, so it's also hard to really account for the energy consumption of anything that you're using. So if you're using an app on the phone, it's easy to know how much energy your phone consumed, but what did it trigger elsewhere, in a cloud somewhere, in a data center somewhere? So accounting is very difficult. Second thing is measuring, metrics. Which metrics are relevant? There's, again, a conflict in interest here because the user wants to be sustainable, hopefully, but the provider might try to hide because it doesn't want to look unsustainable. Maybe it is. So there's a challenge of identifying frameworks that can really provide precise, I don't want to say measures because those are difficult, but at least estimates of energy consumption. And then once we have a way of accounting and measuring, then the real challenge is to say, okay, how do we design systems which are green by design, right? So putting in requirements of sustainability of green ICT as initial requirements, not as afterthoughts as often is done now. And then say, okay, that solution for sure is not going to be a good solution because we will never manage to be green with that solution. There's another issue that is very common on internet and web-based systems that we often do not pay for what we use because there's this advertisement-based model. And with an advertisement-based model, you're not really responsible for the emissions that you cause. So if you watch a YouTube video, you're consuming quite a bit of energy, but it's for free for you because you're watching an advertisement. So the whole CO2 relation to what you just did for you is unexisting. So you don't have any skin in the game, so no interest in actually intervening. So these kind of models are actually economically feasible and maybe good, but from a sustainability point of view, they're very dangerous.
In your team, you have many international colleagues. And this brings me to the question, what makes global collaboration in research so valuable? Perhaps also against what you just said about this affects not one country, not one continent, but the world and the energy consumption of the world, and not least the understanding of the consumer and the user. About these topics. Now, it starts, in my view, on your team, it starts with this international group, which is one of many, of course, in a global perspective. But is this deliberate by you that you have chosen colleagues coming from various countries, as your website indicates, or what can be the contribution of this international team to address such topics as you mentioned?
Yeah, it's a good point. I don't think it's done by design. So it's not that I choose my team to say, I want variety, again, by design. I think it's just a natural consequence of how we work. So I found it very enriching to be able to work with people from very different nationalities. And you see different way of thinking, different approaches also methodologically, so different mindsets. So typically these people come after a master, and where they took the master has an influence on how they start doing their research as PhD students. So I'm in general open to international collaboration. My whole history has been in many different countries. I often say I'm a European nomad, having changed at least 4 or 5 countries in Europe. And this I bring back to in the small of my group. So whenever I have a position open, I want the best candidate. And I typically don't look at gender, ethnicity, or religion. And it is fun when we go, for instance, beyond research for a trip or a field trip together, and you have also time to discuss beyond research. You find so many interesting things about different cultures, different way of doing things, different way of which families functions. So for me, it's always been an opportunity and a resource to be able to work with people of so many countries. And also collaboration, that's the same. I mean, I am open to collaboration. We were 2 weeks ago with a colleague in India where we had the workshop on green ICT, and it was really, really fulfilling to interact with the students in India and then to exchange with the colleagues there. And I've often had projects that were across borders, and I always found them very, very useful and enriching from a personal point of view.
Your personal point of view brings me to one of, I think, your first research stays, work experiences abroad. You worked at Apple's Advanced Technology Lab in the mid-1990s. In my mind, that was a fascinating time in tech history. And mind you, I'm in the humanities, but I saw something is moving. What had the biggest impact on you during that experience at the Advanced Technology Lab?
Indeed, it was an incredible experience for a young man as I was at the time. I saw the world where the things were actually happening, right? So in Silicon Valley, still now, but also then even more, there was all the excitement of the new technologies. At that point, the web was growing and becoming something that was attracting a lot of attention. And you saw a big company, a big technology company, how it worked and how things were advanced. It was actually when I was there that I decided to do a PhD. I was talking with my manager at the time and discussing about career perspectives, and he strongly recommended to do a PhD. It was funny because he told me, yes, Marco, but don't do a new programming language, right? So at the time, too often a PhD entailed just developing a new programming language. And I did so. So I was still a student, a master's student back then. And I did so. I said, yes, I would like to do a PhD when I'm finished to really dig into a topic and possibly have some impact on the scientific community. And the whole 3 months there were super inspiring. I learned a lot. I had incredible colleagues, which all went for very good careers. So it's an experience that I cherish, and I think it was a great start in my experience to then stay in research.
With the vision you developed there, I would assume, what did you expect the future of computer science to look like back then? So back to the past, into the future. And what maybe turned out very differently and didn't come down the road as you expected it to come?
That's a good point. So back then it was 95. The web, as I said, was starting to explode. And I think I had already the understanding that would be major. I was working on common gateways interfaces, which is a basic interactive technology of the web, of the initial web. So that the web would be important and then this networking interaction would be central, that was something that I think we all envisioned. The current AI that we have, I don't think anybody did, or at least I didn't. And to some extent, the AI we have now delivers a lot in terms of human understanding and providing support, and at the same time falls short in providing good intelligence, or intelligence which is explainable and which is reliable. So in that aspect, I think some people, including myself, are a little bit disappointed. And the thing that did happen is this incredible speed of change. So often what we say, that computer science is like a dog. 1 year of computer science is like 7 years in any other kind of research. Things happen so fast. And I see this also, for instance, in my courses. So there's one course which is about fundamental algorithms. That doesn't change much over time. Another one is much more on technology, pervasive technology, smart cities. There, I have to update my content, I don't want to say every year, but almost. Because I talk about a technology and 2 years later, it's gone. Nobody uses it anymore. I talk about a solution and the students don't even know that it existed before, right? So that speed is something that you feel both in research and education.
So the solutions for the future from last year are solutions of the past, in a way, or for the past, and therefore
the very technological applied ones, yes. Often that's the problem. Yes.
Yeah, but still, you emphasize the importance of understanding the history of technology, perhaps also in this context. Why is that especially important for computer scientists today, as everything is so fast moving and changing? Why then the history of technology?
Absolutely. That's a little one of my hobbies. I think it's very important. I'm not the only one, of course, because in computer science, we are a young discipline. Right? We're a young discipline. We're not used to history. We're just there to look at the latest technology. So famous computer scientist Alan Kay said that the computer scientists should be more aware of their past because otherwise they're not a real discipline. And of course, if we compare ourselves with physics or mathematics, there's a huge millennial history there that you're aware of, and it's been important. And in computer science, often we're following the latest trend, and we forget that maybe we've already been there, we've already done some mistakes we could avoid, and so on. And I'm fascinated by the history of computer science. I wrote this book about the web just to try to understand a little bit better how do we got there and what was happening before. And I'm also fascinated about incredible places, research centers. So I was interested in the Bell Labs in the US, which brought a lot of advancements in the 60s and the 70s with Unix and programming languages. Right now I'm reading a book about the NAT Labs of Philips in the Netherlands, which also have brought a lot of technologies, not only computer science, also in many other fields. The Advanced Technology Group with Apple in the 90s and in the 80s was an interesting place. So there's a Xerox PARC. Yeah, Xerox PARC in the US, also an incredible place where so much innovation came and funny enough, not much exploitation. So the results didn't make Xerox rich, but made rich other companies who were able to understand their value and to really exploit it. So I find it very interesting what makes research successful, what is the kind of environment of a research place that brings innovation, and how you should, to some extent, design a research group.
Taking up that very idea about research, the expectation is very often by various players, whether these are companies or society, I guess, as well, to deliver immediate applications. Well, sorry to say, but that cannot always be done. So, especially for a research university, basic research is very, very relevant in everyday life. You strongly advocate for curiosity-driven research. How strong? I'm not calling it resistance against that, but how do you phrase your approach? I hope you don't have to defend it too much, but if so, how do you do it?
So this is a very, very good point, yes. So I think utilization and having a minor utilization for research line makes sense only for some research. Right. So if you're having a line of research which is very applied, it needs to have a goal, and you have an application in mind, then it's fine. You should have maybe even a business plan very early. But I don't think this should apply to all research. And sometimes I have the feeling that some funding agencies put it too central in their line of funding. And I like, again, to cite here someone else, which is Flexner. Flexner is the founder of the Princeton Advanced Studies Center or something like that. And in 1939, he wrote this book, this essay that was called On the Usefulness of Useless Knowledge. And his whole claim is the following, saying, well, we didn't know that some research that was done in the 1800s would have a use, but then Marconi comes and makes a radio out of it. And he uses this word, which I love. He says, Marconi was inevitable. What he means is, like, if you didn't have Marconi, you would have someone else, because the results were there from 50, 60 years before that you could use to build a radio. And I think in many places of research, you could say the same. Right? So, for instance, we have cryptography. Great. Rivest contributed to that. But he used some obscure number theory that was done hundreds of years before by someone who even said, I'm doing this for fun. I don't know what usefulness could have. So, what I'm saying is that having that curiosity-driven research, which might be completely useless today, might mean some important impact later, and we should not kill it. And I even say we should somehow support it. It's not easy because this is not popular, of course. If you have a mindset, a managerial mindset, you say, well, I am funding this when I'm going to see the money back. And with basic research, which is curiosity-driven, you can't ask that. You say, you fund it now, and who knows? But out of lots of useless research, let me use flex in the word useless research, you might have some gems. And those gems you might find much later. And I think that we should not eradicate out that possibility. And it's tough to say, well, I'm giving money to do something which looks useless, but still should be done. That's a little bit my point.
And it reminds me again of the book that you mentioned by Thomas Kuhn, The Structure of Scientific Revolution. And that dates back to 1962. So the very procedure as such, the paradigm shifts that eventually come about, they take time, but they are there. And so that's what society, all of us, yes, need to understand. And I think we are on that way and need to talk about it, perhaps also more here at the university, at the IZKT, of course, at our center that promotes cultural and technological knowledge.
Yeah, so if I add one thing, what I think is that impact is hard to design for, or success is hard to design for. I see it more as a side effect of good research. So we should say, okay, do good research, be methodologically engaged, do things well, and then impact might follow. The other way of looking at things like, oh, search for impact and then design your research is something that, as I said, unless you're in a very narrowed, confined research path, it's somewhat dangerous. So in general, I think success is a side effect rather than a goal in itself.
Mm-hmm. One of the expectations, say in the field of robotics, or that many people have about robotics, is the expectation that of a special relation between humans and machines, or a connection rather than relation, perhaps. Why can an overly human-like robot actually be problematic?
No. So I'm also one of them that has a lot of expectations. I can't wait to have a robot as a housekeeper, but it's going to take time, right? So we were promised something like that by Musk within a few years, and it didn't happen. But I don't rule it out. I hope it actually happens in my lifetime. With respect to humanoid robotics, here there's some interesting thoughts from Rodney Brooks. So there's the famous laws of robotics of Asimov that say that robots should actually well behave and not harm humans. And then he added some new rules of robotics, or laws of robotics, and one of them, it says that function matches or should match looks. So when you see a robot that has a certain look, like a vacuum cleaner, which is on the floor with wheels, you expect it to be able to vacuum and clean the floor. You don't expect it to be able to clean a sink or to be able to empty a dishwasher. The moment you build a robot which is humanoid in all these aspects, it has hands that give you an impression of human dexterity, well, then the risk is that you expect full human functionality from it, or maybe even more. And if the product or the robot doesn't meet that expectation, it's not going to be accepted by the user. And this is the risk we're running. So you see these videos with these humanoid robots that do incredible tasks, but the real point is, can they do it in the wild? Can they adapt to things that are not known at design time? Can they adapt to environments which are different that they were trained on? And if you don't achieve that, putting a product like a robot like that out is super dangerous, especially because it's not going to be successful. So my hope is that we will get there, that we'll have humanoid robots with human abilities or human super abilities. But until that point, showing these human robots is something that I find a little bit risky.
And of course, the good thing about this is that we are beginning to ask these questions. What should those robots actually look like? Not only what can they do and should be able to do, but also how we relate to them as human beings and shape that question. We see it in many media, of course, reflection, but also in science about that. At the end of our conversation, we have a part that we call Moment 7. So 7 questions. Please answer them very briefly.
Okay.
Moment 1. Spätzle or Maultaschen?
Spätzle.
Moment 2. One thing you could change about the world would be?
A more sustainable world.
Moment 3. Do you have a recommendation for a book, music, movie, theater, museum visit?
Many of them. The first one will be my own book, of course, but let's to be more serious. I think the movies of Kubrick are exceptional, and I love them.
Moment 4. The best advice that you have ever received was?
By my manager at Apple to do a PhD.
Moment 5. Your favorite place at the University of Stuttgart is?
My own office, where I interact with my people and my students.
Moment 6. Please finish the sentence. If I could start all over again, I would do the following differently.
Oh, I would buy Apple stocks in the 90s.
Moment 7. Another sentence to be finished, please. Thanks to my studies, I know that
I can learn any technology. Technology change, but I can learn them over time because I know how to learn.
Professor Aiello, thank you for our conversation today about robotics, about basic research, about the understanding of artificial intelligence. As it is discussed widely, I think it was a very good idea to break down some of the aspects from it. So thank you for having come to our studio today.
Thank you. Thank you for having me. It was really fun. Thanks.
And to our audience, thank you for listening in today. Please stay also tuned for our next conversations that are always based on what is made in science.